Imagine walking into a coffee shop, opening your laptop, and instantly connecting to the internet without plugging in a single cable. It feels like magic. Your device taps into invisible waves floating through the air, and suddenly you're streaming, gaming, or scrolling social media. But here's the truth. Wi-Fi isn't magic at all. It's an ingenious combination of physics, radio frequencies, and digital communication that makes the modern world possible. Without it, entire industries would collapse, smart homes wouldn't exist, and our daily lives would feel like stepping back into the 1990s. So how exactly does Wi-Fi work, and why is it so essential in the digital age? The basics of Wi-Fi signals. At its core, Wi-Fi is simply a way of transmitting data wirelessly using radio waves. Instead of relying on Ethernet cables that carry data through physical wires, Wi-Fi uses invisible electromagnetic waves in the air. These waves exist in frequency bands, measured in gigahertz, that allow information to travel quickly between devices and a router. The router is the middleman, translating the data from your internet service provider into wireless signals and sending them out for your phone, laptop, or smart TV to catch. When you stream a movie, join a video call, or send a message, the information isn't traveling as one big chunk. It is broken down into thousands of digital packets. Your router sends those packets as radio signals. Your device catches them, reassembles them, and transforms them back into usable information. The same thing happens in reverse when you upload something, whether it's a photo to Instagram or a large file to the cloud. Wi-Fi is essentially a constant two-way conversation of signals happening at the speed of light. Frequency bands and why they matter. Not all Wi-Fi is the same. Different frequency bands determine how fast and how far your connection can reach. The most common ones are 2.4 GHz, 5 GHz, and the new 6 GHz used in Wi-Fi 6E. The 2.4 GHz band travels farther and penetrates walls better, making it ideal for larger homes or places with obstacles. But it suffers from congestion because many everyday devices, including microwaves and cordless phones, use the same spectrum. The 5 GHz band offers much faster speeds and less interference, but the signals don't travel as far or handle walls as well. The 6 GHz band, only available on the latest routers and devices, is like adding a brand new superhighway with wide lanes and almost no traffic. It enables ultra-fast speeds for cutting-edge applications like virtual reality, cloud gaming, and high-resolution video streaming, though it has the shortest range. Your devices and router constantly decide which frequency band to use depending on signal strength and performance needs. That's why your phone might switch between Wi-Fi 2.4 and Wi-Fi 5 automatically without you even noticing. Modulation and encoding. Sending data through the air isn't as simple as shouting numbers into the void. Wi-Fi uses advanced modulation techniques to encode digital data into radio waves. One of the key methods is orthogonal frequency division multiplexing, or OFDM. Think of it as splitting the radio channel into dozens of smaller subchannels, each carrying its own portion of the data. This reduces interference, increases efficiency, and allows multiple users to share the same frequency space. Modern Wi-Fi standards also rely on quadrature amplitude modulation, which allows more bits of information to be transmitted per signal by adjusting both the amplitude and the phase of the wave. This is like using not just the pitch of your voice, but also its volume and rhythm to say more words in less time. The result is incredibly high data rates that keep getting faster with every new generation of Wi-Fi technology. Wi-Fi standards and generations. If you've ever seen terms like Wi-Fi 4, Wi-Fi 5, or Wi-Fi 6, those refer to different generations of the technology. Wi-Fi is governed by a set of standards developed by the IEE, known as 802.11. Early versions offered just a few megabits per second, while today's Wi-Fi 6E and the upcoming Wi-Fi 7 are capable of gigabit speeds, rivaling or even surpassing wired connections. Wi-Fi 5, based on the 802.11 AC standard, was a major leap forward, using wider channels and multiple antennas to deliver faster speeds. Wi-Fi 6, 802.11 AX, improved efficiency in crowded environments like stadiums and airports, using a technology called orthogonal frequency division multiple access that allows many devices to share the same channel without slowing each other down. Wi-Fi 6E expanded into the 6 GHz spectrum, opening up massive amounts of new bandwidth. Wi-Fi 7, already on the horizon, promises even higher data rates, lower latency, and new features like multi-link operation, where devices can connect to multiple bands simultaneously for even greater reliability. MIMO and beamforming. One of the biggest advances in Wi-Fi is the use of multiple antennas. Known as MIMO, multiple input, multiple output, this technology allows routers and devices to send and receive data streams across several antennas at the same time. Think of it as a highway with multiple lanes instead of a single road. More lanes mean more data can travel at once, leading to faster speeds and smoother performance. Beamforming takes this a step further by focusing Wi-Fi signals directly toward your device instead of broadcasting in all directions equally. It's like a spotlight compared to a light bulb. By intelligently steering the radio waves, routers can deliver stronger, more stable connections even at longer distances. This is why modern Wi-Fi feels much more reliable compared to older versions. Security and encryption. With data flying through the air, security is critical. Wi-Fi networks use encryption protocols to keep your information safe from eavesdroppers. The most common standard today is WPA3, which uses stronger encryption and improved authentication compared to older versions like WPA2. This ensures that when you enter a password to join a Wi-Fi network, the communication between your device and the router remains private and secure. Public Wi-Fi hotspots are a different story. While convenient, they can be vulnerable if not properly secured, which is why using a VPN or sticking to encrypted websites, those with HTTPS, is recommended when browsing on public networks. Wi-Fi beyond the home. Wi-Fi isn't limited to homes and offices. It powers entire industries and cities. Airports, stadiums, hospitals, and universities rely on massive Wi-Fi deployments to keep thousands of devices connected simultaneously. Wi-Fi is also critical for the Internet of Things, linking everything from smart thermostats and security cameras to appliances and wearable devices. In fact, Wi-Fi is evolving to work hand-in-hand with 5G cellular networks. While 5G provides wide area coverage, Wi-Fi offers localized, high-capacity connections in places where people gather. Together, they form the backbone of a hyper-connected world where nearly everything is online. The future of Wi-Fi. Looking ahead, Wi-Fi will only become more powerful. Wi-Fi 7 is expected to deliver multi-gigabit speeds, near-zero latency, and seamless multi-link operation across different bands. This will open the door to advanced applications like cloud-based augmented reality, real-time holographic communication, and ultra-high-definition streaming with no buffering. We may also see Wi-Fi integrate with new technologies like Li-Fi, which uses visible light instead of radio waves for data transmission. While still experimental, Li-Fi could one day complement Wi-Fi by offering ultra-fast wireless connections in specific scenarios. Another future direction is energy efficiency. As billions of IoT devices connect to Wi-Fi, the need for low-power communication becomes crucial. New standards aim to extend battery life for small devices while maintaining strong performance. Why Wi-Fi matters. Without Wi-Fi, the modern digital lifestyle would collapse. Think about remote work, online education, telemedicine, streaming entertainment, and even social interaction. All of it depends on stable, high-speed wireless connections. Wi-Fi allows people to move freely while staying connected, making it a cornerstone of both productivity and leisure. It is one of the invisible forces that defines our era, as essential as electricity or running water. Now that you know how Wi-Fi actually works, you'll never look at those invisible waves the same way again. The next time you stream a movie, join a video call, or play an online game, remember that your router and device are performing a complex dance of signals and packets at lightning speed. Wi-Fi isn't magic, it's engineering brilliance at work. If you enjoyed this breakdown, make sure to hit that like button, Subscribe for more deep dives into the tech that powers our lives, and turn on notifications so you don't miss the next one. Share this video with a friend who still thinks Wi-Fi is just in the air, because the future of connection is here, and you'll want to stay plugged in.